Hello folks, my name is Dr. Zachariah Hildenbrand. I'm here with my colleague Dr. Kevin Shug, and we are the Collaborative Laboratories for Environmental Analysis and Remediation at the University of Texas at Arlington. We're coming to you from the Responsible Shale Energy Extraction Conference, which is a very unique event bringing together scientists, concerned citizens, operators, regulators, and technology companies to have an honest series of conversations about environmental stewardship in shale energy.
We'd really like to thank the support of the Cynthia and George Mitchell Foundation and Earth Day Texas for allowing us to put on this event. We believe that this content that we're going to be providing to those who haven't been able to attend is going to help answer and educate a lot of questions surrounding responsible shale energy extraction. So we hope you enjoy the content.
I'd like to introduce our keynote speaker, Scott Anderson. He is the Senior Policy Director, U.S. Climate and Energy Program at the Environmental Defense Fund. And he's basically the point person on EDF's policy related to the land and water impact of oil and gas extraction activities. So please join me in welcoming Scott Anderson.
Hello, glad to be here. Hope you're glad to be here as well. And I was happy to hear the Secretary end on the note of innovation. I've known him ever since he was a freshman legislator in the Texas House of Representatives, and I know that he's been genuinely interested in innovation and technology his whole career, and being at DOE is in a good position to promote that further. And as you'll hear me touch on, as well as other speakers today, innovation has a lot to do with responsible shale development. I have a little bit different talk to make this morning than I originally thought. This is Earth Day, and I remember the very first Earth Day. I was in high school here in Dallas, Thomas Jefferson High School. One of my classmates, Mary Ann Mayer, was there that day as well, the very first Earth Day. So I thought, well, I'm going to use this to reminisce a little bit. So I got in touch with some of my classmates to see what they remembered about Earth Day. And I got answers like, I don't remember it. And I think a bunch of us rode our bikes to school. And we might have had an assembly, but I'm not sure. So I put this data together with my own memories and came up with basically nothing. And so I'm not going to share any memories of Earth Day with you. But we did collectively remember it. That was very important, but we didn't really remember why. So that brings me to my other topic, which is sustainable or responsible shale development. And I'm going to talk about that, but first I want to make a few acknowledgments. I want to acknowledge and thank Trammell Crow and Clear and University of Texas at Arlington for sponsoring and organizing this, and especially thank Mary Lou Hastings and the Mitchell Foundation, both for being a sponsor of this event, but also being a sponsor of Environmental Defense Fund's oil and gas work. Without Mitchell Foundation support, we wouldn't be able to do a lot of the things that we do. And also, I'll be the third person in a row to give an acknowledgement and a shout out to George Mitchell, who I was privileged in my previous life in the oil business to know George, and I can attest that he was both a brilliant businessman in oil and gas and real estate, as well as a genuine conservationist who believed in balancing commercial development and environmental protection. And how many, if any, there must be some, engineers and geologists in the room? Okay, that's enough for my George Mitchell geologist engineer remark. So one of the things he once told me in a buffet line was that, and I think this is very insightful in a lot of ways, he said, you know, I spent my whole career trying to get my geologists to be as practical as my engineers, and my engineers to be as creative as my geologists. And at least on one particular day, that's how George summarized his career. But he truly is responsible, more than any other single person, for the blossoming or the growth of unconventional oil and gas development by persistently trying to perfect hydraulic fracturing in shale formations and also combine hydraulic fracturing with horizontal drilling. And he was able to unlock the key to how to develop the Barnett, and then that is spread to other tight formations. Which does bring me to the topic of responsible shale development. What I'm going to do here is give a overview of categories of environmental risks posed by modern oil and gas development, and give a little bit of a flavor for where we stand now and what issues are important. Also, time permitting, I'm going to do a little bit deeper dive on one particular issue, which is management of produced water and developments that are underway in that space and what the future may hold. So I would say but before I talk about the risks, I want to make three fundamental points about responsible oil and gas development. First of all, as has already been said, this is definitely an industrial activity. And being an industrial activity, there will be impacts. No matter how much we go about minimizing impacts, there will be impacts. Corollary to that is that it's really not reasonable to think that this industrial activity should take place at every single location. There are places that it simply doesn't make sense to do the development. That said, in our system of government, it's also true that we have a constitutional requirement that says you cannot take somebody's property for public good without paying just compensation. So as a result of that bedrock law, the efforts to totally ban this sort of development are few and far between. And by and large, the question is not whether to ban it in most places, but rather how to have it and regulate it wisely. So that's the first point, that this is industrial development. There will be impacts. Secondly, though, is that the key to minimizing those impacts is to do a good job of identifying and understanding the risks and the impacts, the risk of impacts, as well as doing a good job of identifying and evaluating what the risk control options are, and then to be committed as a policy matter to trying to choose risk control options that reduce the risks as low as reasonably possible. That may sound like a nice technocratic thing to do, but that little word reasonable is very important, and there's no way, no matter how many facts and how much science you assemble and how rational you try to be in deciding what's the lowest reasonable possible risk, there's no way that you can get away from uncertainty, subjective judgments, value judgments, and politics. So all of those kind of things are tied up in any kind of technical assessment of risk management, and risk management in turn is key to responsible development. So that was the second sort of fundamental point. The third fundamental point is that there is no single answer that's good for all time. There's no single rule, no single rule book, no single operating manual that's going to give us the answer permanently for all the various risks that we'll be talking about today. The industry is dynamic. Its technologies change all the time. Its practices change all the time. The places it does exploration change all the time. Our evidence and our science changes all the time. We've already heard a little bit about ongoing research. So as a result of all that, the risks are always changing. Our understanding of the risk are always changing. And the availability of risk control options are always changing. New technologies come into play. Old technologies go down in price. So it's a very, very dynamic space. The implication of that is that since there's no such thing as the answer that's good for all time, for all the problems we'll be discussing today, what's needed instead is a process of continuous improvement. And that's a very, very, very important part, whether you're in a corporate sphere or regulatory sphere. What we're really after, is, if we want to be reasonable about it, is a process of continuous improvement wherein we continue to get better at both at identifying the risks that need to be dealt with and in applying the most reasonable measures to mitigate those risks. So that's kind of where I'm coming from on this whole notion of what does responsible oil and gas development look like in a kind of abstract way. Moving from the abstract to particular risks, I lump the risks, and this doesn't cover every single thing maybe, but most of the risks posed by this development can be grouped into 5 categories, I think. One is well integrity, which is a fancy way of saying that wells should not leak. Secondly, and that's either leak at the surface, leak underground, or leak to the air. Secondly is air releases in this industry that pretty much can be divided into 2 subparts. One is methane emissions, which is far more potent greenhouse gas than carbon dioxide over, say, a 100-year time frame. So methane emissions and then your traditional air toxics, which can be of great concern and potential health impact in certain situations. That's 2. So the third would be, as has already been mentioned, spills and leaks at the surface during operations. And by the way, the data that I've looked at makes me fairly well convinced that there's about 7 times as much chance of getting groundwater pollution from surface operations than there is from a failure of the well itself. Although I believe there's a potential that in some rare instances that hydraulic fracturing itself could cause pollution of the underground water through the fractures, that really, to date at least, all the problems that we're aware of in terms of underground water pollution come from other types of problems with the wells. So 3, surface spills and leaks. 4, waste management. And I'll talk more about waste management in a while, but by far the biggest waste product from oil and gas production is produced water, which is a combination of frac flowback water and native groundwater. More to be said about that later, but 98% of this industry's waste stream is this water. About 2% of its waste stream is drilling muds and cuttings from the rock. Then the 5th and rangiest category is what I would call infrastructure and community impacts. So this is pretty much non-pollution things. Earthquakes don't really fit conveniently into the other 4 things I just mentioned. Socio-economic impacts, the effects on human services in a boomtown kind of context. Safety, fires, stress, aesthetic considerations, traffic, those kind of things, and there's a lot of them, can go into this 4th category. And unfortunately, that tends to be the category where what I said earlier is most true, that there will be impacts. You put industrial activity next to people, there's going to be problems. So that would be my 5th category. So I got 2 more things I want to do here before questions. One is to give a general sense of how well we're doing managing those issues, and then do this deeper dive on the produced water management. And I'm not even going to try to assess how well we're doing on all 5 of those things. I personally only work on 3 of them, well integrity, surface spills and leaks, and the waste management. So from this point forward, as important as the other things are, the methane emissions, the community impacts, I'm not really focusing on that. But with respect to these pollution issues of land and water, we're doing pretty well, but we have a long way to go. And in order to come to grips with the issues, we believe at EDF it's important to focus on sort of 4 different work streams or levels of activity. And the first is science and technology, including innovation, as Secretary Perry is talking about. There's a lot of research that needs to be done to better understand these risks, to develop new monitoring technologies, to develop new remediation technologies, to understand the toxicity of chemicals that we're dealing with. And fair amount of that research is underway, but a lot more of that kind of research and development needs to be done. So that's my take on that stream. And then there's a policy development stream. And a lot of times people kind of skip over that and just think it should be obvious. Well, if there's a problem, we know there's a solution, let's just proceed directly to the goal line. But really, there's lots and lots of ideas out there as to what to do about these discrete issues, and a lot of uncertainty, a lot of disagreements as to the relative priorities. So just deciding what you want to do is, in terms of risk management, is not easy, whether you're a regulator or an environmental advocate or a company. So policy development is a big area that again, a lot of good thinking's been going on, a lot of good thinking currently going on, but even more is needed looking forward. And then there's the one that most people think of first, which is rules and regulations. It would be nice if we could just ask people to be good, and then they would be good, but that's really not the way the world works. There is such a thing as over-regulation, but there's certainly such a thing as under-regulation as well. And I got the same answer on rules. A lot of the shale revolution pretty much took off in Texas in 2005. I guess so, earlier, a few years or before that. Around 2000, let's call it. And it jumped out of the Barnett into the Marcellus around 2008. But most of the unconventional development in the United States has really just begun since 2010. Since 2010, there have been a lot of rulemakings in the state agencies. Most of these land and water issues are regulated at the state level, not the federal level, so that's why I'm talking about the state agencies. And there's been easily 250 rulemakings since 2010 in state agencies addressing land and water pollution issues from oil and gas. And in the last 3.5 of those years, there have been about 120 nationwide. Unfortunately, former Commissioner Porter, only 2 of those 120 rulemakings in the last 3.5 years have been in Texas, which is better than 0. But after a really nice period of time, and I call out former Commissioner Porter because he was also there for this really nice period of time, from 2011 to 2013, there was a tremendous amount of positive rulemaking at the Texas Railroad Commission as it responded to the early days of the shale development. Been a marked slowdown in rules at the Railroad Commission since then, but it requires 2 votes, as Commissioner Porter knows, to get something going. Now the Commission, since I've dinged him a little bit there, I will say that in the last 3.5 years, there's been a lot of progress at the Railroad Commission on the 4th thing I'm going to talk about that's part of the solution. So we've had technology and science, we've had policy development, we've had rulemaking, and the 4th thing is regulatory capacity. It doesn't really matter what your rules say unless you have an agency that's got enough people with enough training, with enough budget, to go out and enforce the rules and figure out. And I've totally lost track of how much time I have left. Do you want to tell me? 2? Okay. So much for my deep dive in produced water management. I'll take a question on it. So I'll just wind up then with development and regulatory capacity. Start with the Railroad Commission. The Railroad Commission has done a lot in recent years to upgrade its data management and computing capacity. They've done a lot to expand the number of field inspectors and to train field inspectors. They've also participated in national groups of regulators who in the last few years have redoubled efforts to again, train agency personnel, but also to try to formalize this process of continuous improvement I mentioned through groups such as Stronger and a newer thing called the State Oil and Gas Regulatory Exchange. But both of these are entities that are dedicated to bringing peers and stakeholders together to review state oil and gas environmental programs to make recommendations on how to improve them. So there's been a lot of activity on that for Virginia, Idaho, and Utah, and just in the last year and a half have all had these reviews and are in the process of implementing some changes. So there's a lot of good stuff going on, and I'll just stop there and see if somebody asks me about water.
Thanks very much, Scott, for the keynote address. I do have, and I appreciate you leaving a couple minutes for questions, because we do have a few questions here. So I'll start with this one. It says, Schlumberger reported that 15% of all gas wells leak methane within their first year of operation, but 50% leak after 10 years. More recently, Ingrafia reported that 50% of wells drilled since 2009 leak in their first year. Why do you say that ground spills are worse than well leaks?
So the Schlumberger article, if it's what I think it is, doesn't really say that. So if there is a Schlumberger article that says that, I need to read it. But what I would say the facts are is that 15% of primary cement jobs fail. There was also a period of time in Pennsylvania the first few years where anecdotally that was more like 30% of primary cement jobs fail. And cement jobs are the single biggest thing that prevents wells from leaking to the environment. But a cement job failing doesn't necessarily guarantee that a well's going to leak to the environment, but it tends to create a thing called annular pressure. And wells with annular pressure are definitely at higher risk of leaking to the environment. And about 5% of the wells on this continent have this annular pressure issue and are at greater risk of leaking to the environment. I think I've read Professor Ingrafia's paper a while back. I'm not remembering it well enough to comment on it, but would you tell me again what that paper is said to say?
He said that 50% of wells drilled since 2009 leak in their first year.
Yeah, I think that was a study that he did on Pennsylvania. I don't think that's quite what that paper says either. But some people, like Yoko Ono and Josh Fox, do confuse the difference between an internal leak in a well, which is what you have when you have that annular pressure problem, and a leak to the environment. So I'm not quite sure at the moment even what he means by leak.
Okay, thank you.
I'm sorry. So the other part of the question was, and so why do I say this other thing? The thing I would cite on that above all is a study that was published by the Groundwater Protection Council, written by a guy named Scott Kell, who studied all the pollution records over a 16-year period at the Railroad Commission and a 25-year period at the Ohio Department of Natural Resources. And for every confirmed, as opposed to alleged, case of groundwater pollution from oil and gas, he got to the bottom of what had been found to be the cause. And about 70% of the groundwater pollution in those two states for those 2 decades was from surface leakage. 10%, and about 20% was from old unplugged wells, which is a type of well integrity problem, kind of special. And then about 10% of the cases that he found came from a variety of what I would call well integrity problems.
Okay, and then probably a final question here. This week, 3,000 barrels of produced water was spilled near the Brazos. How bad is that?
You say near the Brazos?
That's what it says.
So it could be really bad. It might not be. It depends on, it doesn't say 3,000 of what, so I don't know if that's...
Oh, I'm sorry, 3,000 barrels of produced water.
Okay, same answer. But that is my produced water question. So produced water, if anyone remembers the guy named Hannibal, he's the Roman general who conquered Carthage. And after he conquered Carthage, he didn't want them to be in business for a long, long time. So he salted the earth. This is what? All right, we have a better historian here than me. Whoever conquered Carthage did not oil the earth. They salted the earth because they didn't want the earth to be productive. Salt is one of only 1,600 or more, probably more like 3,000, chemicals that are potentially present in produced water. Key toxicity data, according to the EPA, is missing for 90% of those thousands of chemicals, and we only have even test methods to detect the chemicals for about half of them. So the 1,600 are known, the 3,000 is about an estimate. We, in other words, have no solid way scientifically at this point to saying definitively how damaging this produced water is. But we do know this: it depends on what's in it, and it depends on exactly where it was spilled and what it comes in contact with.
I mean, who should be the person? I mean, what should be the protocol for follow-up on something like this, a 3,000 barrel spill, I mean, and how should that be communicated to the public in terms of, allaying fears of exposure?
Well, I'm not sure that allaying fears is necessarily the prime objective. I think the prime objective needs to be to objectively inform the public about what is or is not known about the risks and what's being done to deal with it. It is not good to spill even 1 barrel of produced water, much less 3,000. That is a major spill. And the question doesn't say what it came from, but most likely the Railroad Commission has jurisdiction over that spill. Although it does depend on where in the process that it came from. So yeah, there should be a quick regulatory response, investigation, and public communication on that kind of thing.
Okay, thank you very much. Join me again in thanking Scott Anderson for my talk. Thank you.